Hi, this lecture is on engineering electromagnetics. I am Dr. Kaviran Srikanth. I am an assistant professor in Department of Tripoli, Gayatri Parshad College of Engineering. The focus of today's lecture would be electrostatics in particular. In order to understand a little bit of electrostatics, we first have to understand the motivation behind learning this course and why it is important. The vast grid of Earth's 60 and 50 Hz power transmission line not only supplies the world's electrical need, but their harm is the most powerful continuous electromagnetic signals sent from our planet. This is one interesting aspect. The Earth's magnetic field itself is an interesting area which makes us to study about electromagnetics. The sun's rays, which are also like electromagnetic waves, also motivates us to learn more about electromagnetics. Any device that radiates is coupled in principle by the entire universe. By reciprocity, the universe is coupled to it. These are some interesting aspects that make us to understand a little bit of electromagnetics. And if we also try to understand the aspects of human body and we try to relate how electromagnetics is related to our body, it also emphasizes like the neuronal electrical activity, energy metabolism, genomic responses, neurotransmitter balances, blood-brain barrier permeabilities, whatever phenomena that occur magically inside human body are all powered by electromagnetic fields. So that necessitates us to understand a little bit of absorption of energy from these fields, which necessitates us to understand electromagnetics. The focus, as I told, is based on electromagnetics, which is full of formulas. It typically has like 19 pages of formulas which make electromagnetic theory. It is difficult to remember all, but there are like memory maps for formulas which can be used. For instance, the Maxwell equation integral B dot ds, which is one of the fundamental Maxwell's equation which will be learned, is to be understood as a Maxwell's wellness equation or building science, which is what is intelligence about. So here, the popular books on electromagnetics are Sadiku, Kulkarni, Principles of Electromagnetics, William Haight and J. Work, Engineering Electromagnetics. There are other books which are very popular by Cross and then David Zink and Joseph Minister. So these are some of the popular textbooks, and the first topics of electrostatics start with an understanding of scalars and vectors, and the coordinate system and the transformation. Basically, the transformation in three dimensions is very important to understand electromagnetics. Something like the Cartesian coordinate, two spherical and cylindrical coordinates is a basis for doing some of the problems that are encountered in electrostatics. Then, in particular, for electrostatics, we start with understanding the basic fundamental laws governing electrostatics, which are like the Coulomb's law and the Gauss law. Coulomb's law and field intensity is the first concept that we need to understand. Then the electric field due to continuous charge distribution, line charge distribution, surface charge distribution, volume charge distribution, and then the concept of electric flux density, what is Gauss law and what are the applications of Gauss law in terms of calculation of point charge, infinite line charge, infinite sheet of charge, and uniformly charged sphere are some of the popular examples. Now, to understand simple aspects of vector analysis, you can see like typically two vectors are given which are defined maybe in a cylindrical, spherical, or rectangular coordinate. Then we might have to understand how they are correlated. So here, for an instance, in this example, we try to understand, we are trying to show that the vector fields A and B are everywhere perpendicular to each other. So here, typically we use the dot product and we try to understand. So as such, scalar definitions, vector definitions, which are very fundamental, are very important in order to understand electrostatics. Vector field is a function that assigns a vector to every point in space and is used to model force fields such as gravity, electric field, and magnetic field. So this becomes a basis here. So based on this, here we try to prove the angle between these two vectors is 90 degrees based on the simple correlation based on the dot product, which gives cos theta equal to a bar dot b bar by modulus of a bar dot b bar, where we take the magnitude and calculate, and we see that we get the value of cos theta by based on which we try to show that the vectors are perpendicular. The vector analysis becomes an important aspect in electrostatics because this is a shortcut representation for understanding the different quantities that are represented in electrostatics. Another simple example that I am showing here is how we determine the vector component of A in the direction of A, because the analysis in electrostatics is particularly done with the help of component analysis. So a unit vector perpendicular to both A and B, or a vector component of A on the direction of B, are typical scenarios which we encounter in our uh, electrostatics. So given vector A bar equal to 3ay cap plus 4az cap, and b equal to 4ax cap minus 10ay cap plus 5az cap, how we determine the vector component of A in the direction of B. So basically here is required to calculate the unit vector along B, and then once the unit vector is calculated, we try to calculate the vector component of A along B. So these are simple problems that are normally encountered in electrostatics. So here you can see a bar dot UV cap and UV will be giving us minus 10 by 141, 4ax cap minus 10ay cap plus 5aj cap. So coming to the study of electrostatics, the importance of studying electrostatics can be realized by first understanding how the static charge distribution happens. Basically, is the charge distribution a point charge, line charge, or a volume charge? The static charge distribution produces an electrostatic field. Diverse areas of applications require knowledge of electrostatic field. Devices in solid-state electronics use electrostatic phenomena for different applications. Computer peripheral devices such as touchpads, cathode ray tubes, liquid crystal displays, and electrostatic printers, all of these use electrostatics. Medical diagnostic is a very important application of electrostatics, where we use in electrocardiograms and other sensors which can record electrical activities of various organs. Industrial applications such as painting, paint spraying, and electro deposition uses electrostatic phenomena. Once we have understood that the applications of electrostatic fields are as such immense, we need to understand the mathematical basis for understanding the formulas that are used to develop these applications. Two fundamental laws for electrostatics are the Coulomb's law and the Gauss law, as I mentioned earlier. The Coulomb's law, which is used in finding field due to any charge configuration by the calculation of force, and then the Gauss law applied for symmetrical charge distribution. Both laws are based on experimental studies and are interdependent. Coulomb's law for force, for instance, is given as a force between two charges Q1 and Q2, which is given by F12 equal to K Q1 Q2 by R square A, along the direction of the line joining the two charges, where AR12 would be representing the vector joining the two charges, or the line joining the two charges, where the constant of proportionality K in SI units is 1 by 4 pi epsilon naught, and then epsilon naught being the permeability of free space. In this chapter, as such, the study is confined to free space or in vacuum, and the calculation of the unit vector is done based on the basic fundamental vector calculus. So here, as you can see, if we take the origin point, and then the distance of the origin to Q1 is R1 and distance of Q2 is R2, we can calculate the force between the two charges Q1 Q2 as a proportionality, and then we get F12 equal to Q1 Q2 by 4 pi epsilon naught R square AR12. So which is equal to Q1 Q2 into the distance between them, which is calculated by R2 minus R1 by R2 minus R1 whole cube. So as such, this can be illustrated with the help of a simple example. Let us try to understand. If we take the example of a simple charge of Q1 equal to 3 into 10 power minus 4 coulomb at a point M123, and a charge of Q2 equal to minus 10 minus power up 10 power minus 4 coulomb at N205 in vacuum. And we are trying to find the force exerted on Q2 by Q1. What is that we have to do? So here we first calculate the distance between the two charges, and then the vector distance here is calculated by taking r1 to equal to r2 minus r1, which we take by taking the coordinates and evaluating this particular vector as ax minus 2ay plus 2az, leading to the magnitude of r12 being 3, and the unit vector being the um, vector ax minus 2ay plus 2az by 3, and then substituting the values of q1 and q2 in the unit vector, we are able to calculate the force vector in newtons as minus 10ax plus 20ay minus 28aj. So this is an important aspect of the calculation, which is very fundamental, which we use in our studies of electrostatics, which is used for calculation of electric field and other phenomena.